As you see, I'm introducing you many different versions, one at a time, right? Every model I'm doing here will be a lot more challenging than the previous one. Before I start this investment planning, what is also another challenging formulation, I just want to remark on this orange problem, one final remark, because I had a lot of questions during the break time. Keep in mind, the mathematical model that we are preparing is trying to represent the real scenario that's given to us. What was the real scenario? You have 3 types of oranges, you're going to produce 3 types of orange juice, each sells with a different profit, but there is a minimum amount from each, right? As long as you satisfy the minimum amounts, of course you can sell more with the more profitable one, but you have to make sure that you're selling 100 liters of regular juice. If you put the addition, now anything that you write in the mathematical model should be coming from the problem itself, from the environment. You shouldn't put additional constraints thinking that, well, this is required. If it is not given there, it is not required. That means you're putting additional bounds, additional constraints, so you're actually shrinking your feasible region. We're going to come to those when we're learning optimization. We just give barely what is given to us in the definitions to the mathematical model. The rest will be taken care of the optimization, by the optimization, all right? So, as I said, if all my oranges are grade 3, any juice I'm producing gets an average of 3. Yes, I can label them as superior, but then I won't be selling any, because the environment tells me that you have to have at least this much of regular, this much of premium. So the optimization will say that produce minimum amounts from the less profitable ones and then give the rest to the superior version. Even though I can label the juice as superior, because of the requirements, I might have to label it as regular, because it says spent 100 liters of regular juice. Even though the grade is 2.5, I might label them as regular, because I have to have at least 100 liters of regular, all right? But if you put an upper bound, saying that, well, in order to be regular, it has to be between 2 and 2.2, you're restricting your decisions. That we don't want, okay? It's not if the model says, if the problem says, it has to be like that, then you have to write it like that. But the problem says minimum. Then we have to represent what the problem says, nothing more, right? The optimization will take care of the rest. If you put these two between 2 and 2.2, you might end up with less profitable solutions, all right? Okay. Now let's switch to another problem that we call short-term investment planning. Okay. You have this much of money at the beginning in your pocket, and you want to invest it. All right. Of course, our goal is to maximize our return, right? And we're thinking about the beginning of 2022. So we're at the beginning of 2019 with this much of money in your pocket. You go to the bank and you're looking at your options. Let's see, here are the options. And the bank tells you that there are 4 options. You can invest your money in option 1. Option 1 is for 2 years. Its interest rate is 26% and available this year and next year. Well, it may be available 2021 too, but it's no use for you because it's 2 years investment. If I put it in 2019, it will come in 2021. If I put it in 2021, it will come in 2023. It's way ahead. I need my money in 2022. That's why I don't care about the availability after 2020. So there's option 1 is for 2 years, and it has this 26% interest rate. Nice. Option 2 is a yearly investment. I put the money this year, it comes back next year. I put it next year, it comes back the year after. So it's every year available. And 2021 is the last year I can invest because I need my money in 2022. Option 3, 3 years investment. I put the money now, I forget what's happening, and I got it at the end of 2020, at the beginning of 2023, because it's a 3-year investment. So it's only available now. I can't make it next year. Then I won't get my money in the time I need it. Of course, its interest rate is 38%. These are annual interest rates, by the way. No, total interest rate. And option 4 is another 2-year option, which gives just a little bit more than the option 1, but it's only available next year. It's not here this year. Got it? There are 4 options. I have some money right now in my pocket. I want to invest, and I want to maximize my net return at the beginning of 2023. Clear, right? Okay. In this kind of a setting, what we're supposed to do is we have to balance the net returns and the money I'm putting in. So that's what is written in here. Cash available at time t is actually cash invested at time t plus cash invested prior to t and coming to me this year. By the way, this 12,500, I can invest 500 TL to option 1 now, then I put the rest to option 3, or I may put in some of them in option 2, and I may put the rest to option something else next year. You're gonna plan the whole availabilities, all right? You're gonna plan for all the possibilities. The only thing that I want to maximize what's coming to me at the beginning of 2022. Clear? Now, let's look at these options again. Now, think about it. If you want to use option 4, it's not available right now. So would you stick onto your money, hold on to it, or would you do something else? What would you, invest in 2. It's no use to put under pillow, that because I put 100 TL, I'm gonna get 100 TL if I put it under my pillow. But there is an option 2, yearly. I put 100, I'm gonna get 112. If I want to use option 4, which is only available next year, then I will use option 2 while I'm waiting, okay? Now, if option 2 was not available, we should also think about setting the money aside, some of it to aside. But this time, it's okay. I can put it in option 2, and I can live with it. Yes?
How does the option 2 work? Like, if we invest first our 100 lira, we get
12.
4 lira at the end of the year?
If you invest 100 liras now, you're gonna get 112 next year. Well, that's another decision. If you're putting it option 2 again, for 112, you're gonna get 1.12 times 112 next year. Everything works like that. But every year is then a decision. I told you the decision variable, right? I actually told you the decision variable. What do you think a good decision variable is? What is the decision? Yeah? What are your indices? Yeah? Option. Yeah, so how many variables do you have? Or what is your indices? How about you? Is it 9? I don't know. Tell me the indices.
For option 1 this year, for option 1, well, no, then there's ones that we can't do. Okay.
Doesn't matter. Just tell me the general version. X, IT, amount of money.
To option 1, to option 2.
Amount of money invested in option I at the beginning of year T. Yes, some of the X variables are not defined, but in the most general version, I goes from 1, 2, 3, and 4, and T goes with 2019, let me say it 0, 1, 2. 19, 20, 21. Variable definition clear? Is the variable definition clear? That was what we discussed just 2 minutes ago. Because there is option 2, you don't need to put it under pillow. You can just put it in a yearly investment and I'll get it next year. Yeah? Okay. Let me put a timeline in here. (2019), I'm reporting it as 0. 2020, no. I will learn how to use a smaller board. This is 220, 221, and 222. Okay. All right. There are 4 options. At the beginning of year 0, 2019, do I have option 1 available? Yes. Any money I put in option 1, where do I get it? In 2 years. Right? So this is X11 going out, and it's coming with 1.26 X11, correct? Option 1. Any money I put in 2019 to X11, to option 1, is actually comes in 2021 with 1.26 of it. Yeah? Yes? Of course. That's what we're going to do. All right? What else can I do in 2019? I can put the money in option 1. Can I put the money in option 2? Can I? Let me use option 2s with green. Anything I put in option 2 is called X21. No, these are 0. No, X1, 0. I made a mistake, sorry. This variable's name was 0, so is this, because it's this year. Now this variable is X2, option 2, that I do at the beginning of year 0. When will it come? And how will it come? Next year, it's a yearly event, and I get 1.12 times of it. Any money I put in option 2 at the beginning of this year will arrive next year, right? So it will come with 1.12 times of it. Great. What else can I do now? What else can I do? I'm in 2019. I can invest in option 3, and it will come at 2023, right? So this is X30, and it will come like 1.38 X30. Correct? All right. I can't do anything else in the first year. I have because option 4 is not available in the beginning of 2019. Let's look at 2020. What can I do in 2020? Can I use option 1? Can I use option 1? Yeah, option 1 is 2 years thingy. Yes, I can, so I'm switching to red again. And anything I put in here will arrive in there. This is called X option 1 at year 1. And it is coming as 1.26 X11 in 2022. Right? I'm in year 2020. What else can I do? I can use the daily one, which was green. So I switch to green. I can put some money, and it will arrive in here. Anything I put to option 2 in year 1 will come like 1.12 X21 next year. Can I use option 3? No, it's a 3-year event. It's no use. Can I use option 4? Yes. So let's use, I don't know, pink. And, okay. Bu ne? I'm in 2020. I can use a 3-year thingy. Done. Böyle fancy şeyler yapmıyoruz. Blue. I'm in 2020. I can use option 4 now. And it will come in here. Anything I put option 4 at the beginning of year 1 will come with 1.27 X41. Okay? What else can happen? I'm in 2021. What can I do in 2021? What can I do in 2021? Only option 1. That's the yearly thingy. Anything I put X option 2 in year 012 will arrive 1.12 option 2 in here. Got it? Okay. So my variable is xit. I124 T012. Now tell me the objective function. What do you want to maximize? Everything is on the right. I want to maximize my net return coming to me at the beginning of 2022. By looking at the colorful thingy I've drawn on the right, try to come up with what am I actually getting at the beginning of 2022. Yes? Exactly. That's what we're going to do. That's what we're trying to maximize. We're trying to maximize what I'm getting at the beginning of 2002. So what is it? It's 1.26 X11 plus, what else? 1.38 X30. What else? 1.27 X41 and 1.12 X22. Right? Is X10 coming in 2022? No, it's not. Anything I put in X10 is actually in X21 because it arrived in 2021. I have to invest it again or put it in under my pillow, which is meaningless. That's why I don't see X10 there, right? That was a good question. Did everybody get it? I only see the ones that are coming in 2021. Those are the things I'm trying to maximize. The rest will be handled in the constraints. I have to write cash flow balance for every year. Clear? Clear? Are you with me? So? If not, ask me. Don't take a picture, write it down, please. come on, it's just 4 numbers. Yeah. Is it clear? Yes. Next time come with a piece, or you get a minus. Yeah. There was a question somewhere here. Huh, yeah.
I think I couldn't but 1.26x11, okay. 2022.
Yeah.
But is it not just 2020 and 2020 arasında değil mi? Ondan öncekileri katlamış olmuyor mu?
That's what I'm saying. Now be careful. I'm trying to maximize what I'm getting. Let's write the constraints. What do I have? Subject to. I have 12,500 at my pocket right now. What am I going to do with this money? What can I do with this money? I can put it in x10. I can put it in x20 or x30. That's all. That's how I named my variables. Anything going to option 1, 2, or 3 should add up to my total money in my pocket right now. What's happening next year? Next year, the only thing I have in my pocket is 1.12 times x20. That's all. Because anything I decided to set aside to use in 2020 is actually used in yearly investment. Now, what am I doing with these? I can put it in another yearly investment, which is x21, or I can put it in x11. It will arrive in my objective function. Or what else can I do? 2020, I put this. There is this x41. Is it clearer now? Because this cumulatively calculates everything. Now at year 0, I put my money, maybe none of them, maybe I put everything to yearly investment, which is x10. And in 2020, I will differentiate. Or I put everything in x30, then nothing is left for the other years. Okay? You just make the decisions based on the flow balance. At year 0, I have all my money. I can put it in option 1, 2, or 3. That's what if you're okay with what the right side of the board, now we're ready to formulate the problem. But if you're not okay with right side, we have to discuss. Yeah? X40 is option 4 at now. Option 4 is not available in 2019. And what was your saying else? 2, 2, option 2, X22, I have X22. It is in its correct way, place.
Okay, I didn't see X40 was possible.
Okay, okay. Anything else? I drew this colorful cash flow graph to represent what's written on the table, right? Now I'm going to use this graph to write my formulation. All I'm doing is, let's look at the constraint. At the beginning, I have 1,200 and 5,000. 12,500 TL. I can put it into yearly option 1, because in here only option 1, 2, and 3 is available. So at the beginning of year 2019, I'm putting my money in option 1, 2, or 3. Okay. I won't set any money aside because there is this yearly investment. That is meaningless. Now, in 2020, if I have invested in a yearly option, anything I invested previous year on a yearly option is X20, right? That will come with multiplied version of it. So anything coming to me at the beginning of 2020 that I can invest again is 1.12 times X20. If I left some money, it will be here. Otherwise, it will go, if it is 1, 0 or 3, 0, I will deal with them when I'm writing the constraint of that year. Okay? So let's write the whole constraints in here. 12,500 equals x 10, 20, 30. This is 2019. 2020, what do I have? 1.12 times x 20 will be invested in, I'm in year 2021. I can put it in yearly option again. I can put it in the option 4 is available, 4-1, and option 1 is again available. Yeah? I'm in year 1, I can use option 1, 2, or 4. I'm in year 2020, look at my table. In 2020, I have option 1, 2, or 4. So any money coming that I can use in here is any money I didn't use in previous year or I just invested for yearly investment. And then I can put them in the investments that are available for me at the beginning of 2020. Okay? Now let's write the constraint for 221. Any money coming to 221 is anything I have invested in the X10. It was a 2-year investment. Now that money will arrive with 1.26 times X10 plus anything I invested yearly next year, which is actually 1.12 times X21. This is the money that's coming to me in 221. What can I do with it? I can only put it in a yearly investment, which is 22. In 2022, I'm trying to maximize that. So what is coming to me in 2022? 1.26 of X11 plus 1.38 X30 plus 1.27 X41 plus 1.12 X22. I don't know what's that happening. This is flow balance, cash flow. I started year 0. I have written flow balance of every year, and I want to maximize what's coming to me at 2022. Clear? Any question? Would you be able to do such a formulation by yourself now? Yes? Yes? You got it or not? Yes. Where? 2019 to 2021. It's not X4. X4 is option 4, and option 4 is not available in 2019. Good, thank you. What else? Anything else? Be careful. Preparing this colorful graph is the key to formulate this problem, right? It helps a lot. It represents the life in a graphical way, and by using this, we can formulate our problem. Yeah? Any questions? If not, I'm going to another one. Yes? Because that's the money I'm getting. That's the flow balance for 2022. If I were to invest again, the one that I've written here are the things coming to me in 2022. Anything I've invested in year 1, which is 2022 for yearly option, 2-year option, the things I have invested in the 2019, the one in the second year 220, and the things coming from last year. That's what I'm trying to maximize. Yes? Yeah. If we didn't have the 1-year option, we will define another variable, any money that I'm not investing in this period. That would be X5T. So that would represent the money that you're not investing, and it will come as it is. Since every year there are different options, you should also include that. Okay, did you get the question? If yearly option was not available, then you should think about not using the money this year as a different option. So you will have X5T in your formulation saying that the money I'm not using this period, because I'm going to use it next period for the second option, for the fourth option, which is more profitable. All right? So if the yearly option was not available, we should have defined another variable to represent the money that I'm setting aside under my pillow, not investing for this year. But since the yearly option is available, it's meaningless. Even you can define it, but at the end, it will always be 0. Any other question? Yes?
What will you do after choosing option 1?
Option 1 in the first year arrives in 2021. Then we have to put it into option 2, which is the yearly investment.
It represents say with the choosing option 2 all the way.
No, because, look at this constraint. Okay, this constraint says anything I put to your option in the first period will come with this multiplicator. And anything I invested last year, yearly, will come like this. I have to invest it for the option 2, because here only that's available. What you're saying is option 2 all the time. That is in here, actually. The 2-1 in here is actually coming from here. So cumulatively, it's actually, if that's best, it will the optimization will select option 2 all the time if that's the best option. And it is included in the formulation. Any other question? All right. Another problem then, product mix. Okay. More and more challenges. We're producing milk chocolate, okay? For 1 kilo of milk chocolate, I have to have half a kilo of milk, 0.4 kilos of cocoa, and 0.1 kilo of sweetener. Only this combination makes 1 kilo of chocolate. If I have like 0.6 kilos of milk, 0.4 kilos of cocoa, and 0.1 kilos of sweetener, I will still get 1 kilo of milk chocolate, okay? This is like 1 car requires 4 tires and 1 steering wheel and that kind of thing. You have to have, with this combination, then you will get your 1 kilo of chocolate, okay? Half of it will be milk, 1/10 will be sweetener, and 2.5% should be cocoa, all right? Of course, I have to produce these things, right? Let's see. Now, I have 2 departments, 2 machines that are working, and each department can process these things in different hours. For example, for department 1, milk is produced, well, for each kilo of milk, department 1 requires 0.4 hours. Department 2 requires 0.6 hours. For each kilo of cocoa, department 1 requires 0.3 hours, department 2 requires 0.2 hours. Okay? And for sweetener, department 1 requires 0.5 hours, department 2 requires 0.6 hours. Each department have 150 hours available right now. Okay, let's maximize the number of milk chocolate we can have, the kilos of milk chocolate we can have with these settings, restrictions. Got it? Is the problem clear? In terms of production, it's easy. I have 2 departments, 3 different things, milk, cocoa, sweetener, and then I will end up with chocolate. Let's define the variables. Huh? Pardon, yeşil kalmış. Çevireceğim. What are my decision variables? Yes.
X and where I is about 1, 2, and X, CI, everything.
Milk, chocolate, milk, cocoa, and sweetener. Okay, I'll do it like Xij this time. Number of kilos of ingredient I processed in department J. So I can be milk, I'm going to say it 1, cocoa, I'm going to say it 2, or sweetener, and I'm going to say it 3, and J will be 1 or 3. Okay? Xij is actually the number of kilos produced of each type in each department. I will define another variable because we're going to need it later on. Kilos, number of kilos of milk chocolate produced. It is a chocolate produced. It's actually what we call induced variable because normally your Xij actually tells you how much your Ys are. But let's define it because we need it in the formulation. Okay. I'll leave the objective function for a while, but let's write the constraint. So I'm going to maximize whatever it is. We'll leave it for a while, but let's write the constraints. Let's start from the easy ones. How about you write me the constraints that department 1 cannot work more than 150 hours. Department 1 cannot work more than 150 hours. What is the constraint for that? Come on. Yeah, how about I hear from you this time? What was it, scan? X11, definitely, plus? Is it 1, 2, or 2, 1? Cocoa in milk, so it's 2, 1. Plus? Less than or equal to 150. I can't use more than the hours available. The other constraint is 0.6x to 1, 0.2. Is it 1, 2? Yeah. Thank you. 1, 2, 2, 2. Yes, but this is 0.2x22 plus 0.6 x32 shouldn't be more than 150. Yeah, this was the easy part. Yeah? Okay. How many chocolates am I producing? You need this stat right now. For 1 kilo of chocolate, I need half a kilo of milk, 0.4 kilos of cocoa, and 0.1 kilos of sweetener. So what actually determines my number? Yes?
X11 plus X12 divided by 0.5. Am I going correct?
You're going correct, but what are you going to do with it?
Plus.
I opened a new table, plus.
Sorry, that's all.
No, it's not all. Now, you're in the right track. Let me write this. You said what? X11
Plus X12 divided by 0.5.
What is this? This represents the chocolates I can produce from the milk I have. Because for each kilo, I need half a kilo of milk. So this is what I can have in terms of chocolate. For all the milk I have, I can have this much of chocolate. if I have 4 tires, I can only have 1 car. So 4 tires divided by 4 gives me 1 car. That's why. With points, it's not easy, right? I know. If it was like 5, I need 5 kilos for each kilo, you would divide it by 5. So this is the number of kilos I'm having in terms of chocolate from the milk. Yeah? How about from cocoa? Sorry. What do I need to write in here?
We should write 3 of them.
Huh?
Sweetener and take minimum.
Exactly. Thank you very much. So x2, 1 plus 2, 2 divided by 0.4 and x. Why am I writing 0? Allah Allah. Silgime ne oldu? Huh. Okay. x3, 1, 3, 2 divided by 0.1. I want to take the minimum, and this is actually the kilos of chocolate I'm producing, right? For each, you don't know how much you produced. You look at your milks, that will give you this much. From your milks, you will get this much of chocolate. From your cocoa, you will get this much of chocolate. And from your sweetener, you will get this much of chocolate. The minimum will tell you how many chocolate you have. It doesn't matter if you have like 20 wheeling tiers. If you only have 4 wheels, you will only have 1 car. Yeah? It's exactly like that. Clear? Clear? All right. Now, is this linear? Minimization function. Since I'm asking it and it's on a different board, apparently it's not linear, right? So first of all, what am I maximizing? I'm maximizing y. That's my chocolate, right? Now I have to write the equation linking y's and my x's. Because if that's it only, my x's, all x's will be 0 and my y will be infinity. I have to tell the model how that y is actually the minimum of these 3 things. Any suggestions? Maximize y, subject to. How do we write this? Maximize y, subject to. Y is the minimum of these 3. Y is minimum of 3, 5, and 8. How would you write it? How would you write it? If you don't write anything else, your optimization would make y infinity, right? So you're trying to put, you have a suggestion?
Maybe if we could write each one of the equations as weight related to y.
Yep, exactly. Y is less than or equal to x11 plus 12 divided by 0.5. Y can be at most the chocolate I can produce from milk, or it could be at most the chocolate I can produce from cocoa, or it could be at most the chocolate I could produce from sweetener. 3, 1 plus 3, 2. Yana da geçti. Yeah? Let me do it. Oh, işte tahta silmeyeyim. Burada varmış. Okay. So we're maximizing y subject to y is, no, y cannot be more than the milk. Also, y cannot be more than the cocoa. And y cannot be more than the sweetener. Also, I have to have the less than or equal to 150 constraints. And I have to say that xij non-negative, y non-negative. Clear? This is actually product mix type of formulation. The minimization of a couple of terms can be represented as everything. So normally, the optimization would try to make y as large as possible, but then it will be bounded about by the limitations coming from milk, cocoa, and sweetener. If the milk says you can produce 9, cocoa says you can produce 8, and sweetener says you can only produce 1, my y is 1. All right? Is it clear? Yes? No one is choosing anything. I'm writing in a linear programming here. So I managed to write the minimization function as linear inequalities on the left. Because minimization is not a linear function. That's why we have to... We're not going to choose anything. We just teach the mathematical model that the y thingy is bounded above by those 3 terms. That is actually, the minimum of it, of course. Yeah. We're trying to represent the real life in this mathematical model, right? So that when we optimize the model, everything will be correct. Any other question? Okay, there's one final model that I wanted to do, but the time is not enough. So we're going to continue on oh, yeah. Hold on.
Is the model thinking about the waste that we might have? Because since we're taking the minimum, maybe if we have extra and we don't want that.
If they have, like, this is what you're trying to not to do right now. We only represent what's given to us. If any extra production has a cost or something, it would be written in here. What I said is maximize the, so at the end, of course, it's meaningless to produce more, but if you don't put anything else in the model, the x variables can be more. We may, but in order to eliminate that, I have to give you more information, saying that as long as 150 is satisfied, maybe everything is used. Check Piazza, be active in Piazza. There's going to be a discussion going on, and we need you to be active there. On Monday, you will have first handout, and next week, we are going to start practice sessions. So you do, not Monday, today you will have your first handout. The handing in is due Monday, with an option to update it after your practice sessions. In the practice sessions, we're going to solve those homeworks together also, all right? But we have a normal lecture on Monday again in here. Now let's look what we're gonna formulate today. The topic is error minimization problem. So now we're considering the stock price of a beverage, all right? And we know the past data. According to past data, look at the thing. We have 5 days data, all right? And we're trying to predict a relationship between the amount that we sell in the market and the stock price of the company, all right? According to the data, well, for example, in day 1, we sold 10 beverages, and our stock price was 2 units. The day after, we sold 12 beverages, and the stock price was 3. On day 3, we sold 8, and the stock price is back to 2. Right? So we have like this. So our motivation, now if we actually were to plot this, why is it not working? So we have certain points around. If this is beverages and this is the price, all right? We're trying to predict the relation between number of beverages and the sold prices. Right? Stock prices. We are going to try to fit a linear line, all right? So we're assuming that stock price is like this. stock price is a percentage times the number of beverages sold plus an intercept, whatever it is, right? So that's the line we're trying to predict. Now, when we're doing this, we're actually trying to minimize our error, right? We're going to predict a line. So this is primitive forecasting, yeah? So I will come up with a line for this. So let me find the line with the minimum possible error. Did we get this? Clear? Now tell me the variables then. What is my variables this time? Decision variables are what? Come on, what are the variables? What do you want to find out? A and B, exactly. I'm trying to find the line, right? So my variables are my coefficients A and B. Yeah? Okay. I want to make sure that my error is as small as possible, right? So let's bring back this data and let's write then. What is my error? For any day, error at day I is what? Day 1. What is the error in day 1? Normal stock price is 2, but I'm going to predict something else, right? So isn't it this? It's the absolute value. I can predict less or I can predict more. So normally my error is this, right? 2 minus A times 10 minus B. No? Because this part is what I'm predicted for the S value, right? I'm assuming it's going to be 10A plus B, but then it is 2. So the error is the actual stock price minus whatever I predicted for that, but I want to take the absolute value because I can predict less or more depending on my A and B. Is this clear for everybody? This is the error for day 1. I will have errors for all those 5 days, depending on my A and B. And my main motivation is to minimize choose the unknown coefficient such that the largest error is as small as possible. So I want to look at the largest error, and I want to minimize that. Is this clear for everybody? Is everybody with me with the fact that the error is the absolute value minus this 10A minus B? Yeah? Because that's what I predicted for day 1. And what happened in day 1? Well, the price was 2. So the error for day 1 is this. Tell me the error for day 2. What is the error for day 2? You need this? Yeah. Now tell me the error for day 2. I can't hear you. 3 minus, but it's in the absolute value. Yes, 3 minus 12A minus B. Yeah? Correct? Okay. We will have day 3, 4, 5. So I want to minimize the maximum of 5 terms. The error of day 1, 2 minus 10A minus B. The error of day 2, 3 minus 12A minus B. The error of day 3, 2 minus 8A minus B. Day 4, 3 minus 11A minus B. And day 5, 4 minus 14A minus B. Right? This is what I'm trying to do. Minimize the maximum. I'm sorry. Hopefully I will get better at one day. I don't know when. Clear? Any questions? Do I have any constraints? This is my objective function. Yeah? My variables are A and B. This is my objective function. I'm trying to write the LP. Yeah? Does this look like an LP to you? Why not? We don't have constraints. Okay. Just find A and B's. So A, B in R2, they don't have to be positive. So it's okay not to have constraints, depending on, yeah. Yeah. Okay, so how do we linearize this? Not linear. Yeah? What are we supposed to do then? Yes?
Something like maximize y and y is less than or equal to x.
Are we trying to maximize y? Minimize y. Y is our error. So yes, this is the trick we used in the chocolate thingy, right? So we're going to minimize y, where y is what? Maximum of 5 terms, right? Still not linear. We have to get rid of this max. How do we do that? You were saying it. We're going to minimize y subject to each term. Yes, what were the terms? 2 minus 10a minus b. Y is at least 3 minus 12a minus b. Y is at least 2 minus 8a minus b. Y is at least 3 minus 11a minus b. And y is at least 4 minus 14a minus b. Is it good? Is this linear? Let me wait so that you finish writing. Is this linear? Is the absolute value function linear? Come on, high school. No. Still not an LP. We have to get rid of the absolute values. Well, I'm not going to teach how to do that, but I did it. So the one on the left, which has nicer writing because I did it in my office, gets rid of the absolute value, yeah? Now, the one on the left is the correct formulation for the error minimization problem. I'm supposed to find coefficients A and B, and actually, I'm minimizing my error, largest error, and I represent my largest error with the variable y. I'm trying to minimize that y, and y will have certain bounds. I want to make it as, if possible, I want it to be 0. But there are certain things that may not lead to that, because y has to satisfy those conditions that I've just written, right? For each absolute value, there's a plus and a minus version of it. And since y is actually the value of the absolute value, the resulting y is non-negative, of course. All right? Clear? This is the last example for linear programming examples. Your homework 2 is actually composed of certain challenging questions that we can come up with from LP that we will discuss tomorrow and the day after in the small practice sessions. All right? Now I'm switching to another modeling problem, which we will have integer variables. But I'm waiting until you finish writing this whole thing. Are you done? Almost. Okay, this finishes LP.